Okay, welcome to a quick video about converting recurring decimals to fractions. If the recurrence starts straight away, it's the easiest type of question to answer. What we need to do is let x equal the decimal they've given us. What I'm also going to do here is find 10x. Now 10x here is 7.7 recurring. If you remember, effectively we're making the decimal point move one place. We're not really, but it's sort of what's happening. The reason I've chosen 10 is because I only need the decimal place to move once to allow the recurrence to continue. What I'm then going to do is subtract. So 10x minus x is 9x, and 7.7 recurring minus 0.7 recurring is just 7. These 0.7 recurrings just go away because we're taking them away. Now if x is 0.7, if 9x is 7, then x must be 7 over 9. So here I'm going to do the same sort of thing again. I'm going to let x equal 0.83 recurring, but this time, to get the recurrence starting after the decimal point, I need it to move twice. If only times by 10, I'd have 8.3838, and it wouldn't match up with the 8383. So here, I'm going to have 100x is 83.83 recurring. And then, as I did before, I'm going to do a subtraction. 100x minus x is 99x. 83.83 recurring minus 0.83 recurring is just 83. So x is 83 over 99. So these are the same types of questions. This line is just a different way of showing a recurring, so it means the same as 0.746 with dots over. So again, I'm going to have x is 0.746. It doesn't matter if I change it into dots, I'll keep it as a line. This time, to make the recurrence start, I need to move the decimal point 3 places effectively. So I'm going to say 1000x is 746.746 recurring. It's exactly the same. I'll do my subtraction, so I get 999x, 746, so x is 746 over 999. And even if I start with a whole number before the decimal point, so 3.25 recurring here, I can still do the same. So 3.25 is x. To allow the recurrence to start, I need to move everything 2 places. So I'm going to have 100x is 325.25 recurring. Just be careful here when you do your subtraction, that's still 99x. The 0.25 recurrings go away. But here I don't just have 325 now, I have 322 because you've got to take away that 3 as well. So x is 322 over 99, a top-heavy fraction. It just gets a little bit trickier if the recurrence doesn't start straight away. So here I have 0.32 recurring, so it's not the whole 323232, it's 0.32222222. Starting the same way, I'm going to have x is 0.32 recurring. But I just need to be a little bit more careful with my multiplying. If I times by 10, I will get a recurrence of the 2 straight after the decimal point. I'll get 3.2 recurring. But if I then try to subtract 0.32 recurring, can you see that the bit after the decimal point isn't just going to disappear? So it's really not very helpful. It's not what I'd be after. So what I have to do is also times by 100x. So if I times by 100x, I'll still get the 0.2 recurring afterwards. I'll just have 32.2 recurring instead. Now I've only got the 0.2 recurring after the decimal point. I can do my subtraction. 100x take away 10x is 90x. 32 take away 3 is 29. And the 0.2's disappear because I've got 0.2 recurring take away 0.2 recurring. And that's why I couldn't use the 0.32 recurring straight away. So now I have x is 29 over 90. So this question is going to be exactly the same sort of idea. Just remember it's only the 6 and the 3 recur. So this is 0.5636363. First thing I'll do is let x equal 0.563. Then I need to decide what I'm going to multiply by. But I'm going to multiply by 10 to start with, because I'm going to get 10x is 5.63 recurring. And the way I know to times by 10 is it brings the decimal point to just before all of the recurrence starts. What I'm then going to do as well is multiply by 1,000. So I get 1,000x. And the way I know to do that is because I've now got the 6 and the 3, so the bit that's recurring, it's the left-hand side of the decimal place as well. So this is 563.63 recurring. So notice that on the right-hand side of the decimal point, we've got the recurrence, and just in one of them, I've got the recurring numbers on the left-hand side of the decimal point as well. So I'm going to take away, so I get 990x is 558. So x is 558 over 990, which of course you can then simplify using your calculator as well if you wanted to 31 over 55. Back to the same idea again. So just going to look at one more. We're going to do exactly the same sort of thing again. The first thing I'm going to do is let x equal 3.2974 recurring. Now here, exactly the same idea as before. I want to work out how many times I need the decimal point to move, so what I need to multiply by to get the recurrence on the right hand side of the decimal. So that's going to be times 100, so I get 100x equals 329.74 recurring. Now I want to get the recurring bits, the 74, just the left hand side. That's 1, 2, 3, 4. So I'm going to have 10,000x is 32974.74 recurring. And what that's allowed me to do, if you look here, is I've got the recurring bit after the decimal point, so when I take it away, it will all go. So I'll do my takeaway, so I get 9,900x is 32645. So x is 32,645 over 9,900, which again you can simplify if you want to 6,529 over 1,980. Hope that's helpful. Thanks very much.